This video deals with finding probabilities from a contingency probability table and from a probability tree. These are from your lecture notes 6 and chapter 4 from the textbook. What we have here is a problem where 500 Peoria County homes were studied, and let's assume that there are only 4 types of siding. And so brick, stucco, cedar, and aluminum. So that's going to be our collectively exhaustive set of outcomes for house siding in Peoria. And then, of course, we're looking at whether they termites were present or not present in those homes. So that's another set of outcomes. And so we construct a contingency table. We found that 75 homes were cedar and that there were termites present in those 75 homes. We found, and there were 200 total cedar homes. So you can tell then that 125 did not have. So we can finish that table out. And that's our first job then, is to take these numbers, these partial information here, and complete the table, which I've done at the bottom here. And so based on what we have knowledge of, we can complete the table, because we know that there are 500 homes, and so then we can work from there. We know that there are then would have to be 150 that are have termites present. We know that there has to be 110 stucco homes, because these two would add up to 110, and then these 3 plus this unknown here would have to equal 500. So we can then figure that out now that we know that this is 110, and so on. So then we can get these real easily, and then from all that information we can get the 10 and 50, because we know that these 4 numbers have to add up to 150, these 4 have to add up to 350. So we have our completed frequency table, and you might get a problem like this. You might get it out laid out in text form, and either way, then whatever information is given to you, create a contingency table, and if it's a frequency contingency table, that's fine. So we'll have this, and then we would need to move to a probability table. And you know that from working with relative frequency tables from the organizing data section, that's just taking each value here from the frequency table and dividing by the total number, the 500. So then we could just copy and paste that. Okay. And so now we have a probability table. We see that 25% of all the homes are cedar and do not have termites present. 20% of all the homes are aluminum and do not have termites present. 30% of all the homes have termites present. Okay, and so on. So we could interpret that in various ways. And what we'll do is we'll use this then to answer these various probability statements. So for example, probability that termites are present, and remember this symbol is and, the home is cedar. That's a joint probability. So that one's basically given to us, cedar and present. So that's just this cell right here. What's the probability that the termites are present and termites are not present in a home? Well, that can't happen, right? So that's not even in this table, which means that it's 0. Probability is 0 that could happen. Probability that the home does not have termites present, or, now this symbol here is or the home has termites present. Well, that's the rule of addition, where you're adding up all the marginal probabilities and then subtracting the joint probability. Well, in this particular case, you have the 2 joint probabilities, so not present plus probability of present minus the joint probability of those? Well, we already said that that's 0. So in this particular case, because present and not present are collectively exhaustive here, the probability adds up to 1. Okay. So then you got probability of stucco or not present. Well, same idea, but now you're going to have a joint probability that comes into play. So stucco 0.22 plus not present minus here, otherwise you're going to double count. So you got to subtract that out, so you get 0.77. Okay. So now conditional probability. This says, well, what if I know that the home that's picked at random has termites present? Okay, so if somebody has told me that, what's the likelihood then that it's a home that has aluminum siding? Well, if you recall from the notes, that is the joint probability of those two events, aluminum and present, divided by what's given here, present. So 0.3. Okay, so I know that there's termites present, so I can say that, well, then the likelihood that the house is aluminum is 0.2. The probability of not present, that's just called a marginal probability. That is the sum of all the joint probabilities that include not present. So not present brick, not present stucco, not present cedar, not present aluminum, add up to 0.7. Okay. And then another conditional probability, not present and present, well, that's the joint probability divided by the marginal probability of present. Well, we know the joint probability is 0. So 0 divided by 0.3 is 0. And that should make sense. I know that the house has termites present. What's the probability then that it will be a home that doesn't have termites present? Obviously 0. So now we have a situation where we'd like to know whether two events are independent of one another. And all that means is, if I know the occurrence of one event, does that change the probability of the occurrence of another event? So basically, is this true? The probability of C given NP, so the probability a house is cedar given that we know that there's no termites present, is that exactly the same as the probability of a cedar home? So the probability of picking a house at random and it being a cedar sided home is just simply right here, 0.4. Right? So the question is, if I know now, if I limit it to this group here of not present, so 70% of the homes rather than all 500 of them, will that matter? Will that change the probability that it's a cedar home? Well, let's find out. Let's take the joint probability of cedar and not present and divide by not present. And obviously that's different from 0.4, so they are not independent events, statistically independent events. So if those had been the same, then we would say those two events are independent of one another. But in this case, that's not true. So that's dealing with contingency tables, probability tables, and finding different probabilities. Let's do something similar with probability tree. And so now we have the exact same problem, but it's going to be laid out differently here. We start with the marginal probability, and then you could do this two ways. You could start out with the siding first and have their marginal probabilities, and then so you'd have 4 lines here, and then 2 and 2 from each node. But here I chose to go with starting out with termites present, so I have present, not present. So then off of each of those branches are 4 more branches that represent the 4 different sightings. And so what's different from the contingency table is you have these marginal probabilities, which is fine. You have, they're in the contingency table, but these are now conditional because we have this as already occurring. We have the house has termites present, so what's the likelihood then that it's a brick home or a stucco or cedar or aluminum? Okay, so to get these numbers, I had to take the joint probability, so say of brick and present, so 0.02 divided by 0.3. Okay, so that's the 0.0667. And then I took stucco and present, okay, and divided by, so 0.07 and divided by 0.3. So we got 0.233. So these are all conditional probabilities. So that's very different from the contingency table. And then what I do is I multiply these out right here. And so I'm multiplying through here to get my joint probabilities. And here's another joint probability. So I'm multiplying through these set of branches. And so that's what all these values represent, is just multiplying through the branches. And so I have my joint probabilities out here and my conditionals. Now these may not change because you could have independent events, say for example flipping a coin. So true and false, so this would be 0.5 and 0.5, and then I'd have 2 branches coming off here. Well, it'd still be 0.5 and 0.5, so it really doesn't matter, because those are independent events. But it still plays out the same. You would still multiply through to get your joint probabilities. So now that you have this, you can answer various questions. I didn't pick as many for this, but probability of stucco, well, that's taking every joint probability that involves stucco. So that's this joint probability here for the S, and then down here for this S. And so that's 0.22, and that should be confirmed here. That goes along with that contingency probability table, so that works. Probability of stucco given termites are present, so we're going to go off of this branch here and look for stucco, and that's just right there, 0.233. So that one's pretty easy. Okay, but now based on this tree, let's go the other way. What's the probability that termites will be present given we know the house is stucco? Well, probability of stucco and present, so here's present and stucco, so that's just 0.07 divided by what's given, the probability of stucco. Well, we already figured that out, 0.22, so 0.3182 would be our probability of the house having termites present given it's stucco. And you could see that works here as well. So present and stucco given divided by stucco. Okay, so that's probability tree and contingency probability table. If you have any questions, let me know.